Hi guys, welcome back to my mathematics tutorial, and my name is Peter C. Dogbo Jr., math instructor at the University of Liberia. So in this video, we'll be looking at the proofs of some properties or the rules of differentiation. So in previous video, I did the proof of the constant rule, constant multiplier rule, the sum or the difference rule, and the power rule. So in this video, I want to do the proof of the product rule. So to start with, we say if f of x and g of x, so forgive me if I just like using f of x and g of x, but I could use h of x, p of x, q of x, just any functions to represent two distinct functions. So if f of x and g of x are differentiable functions of x, then the derivative of the product of these two functions will result into f of x times g prime of x plus g of x times f prime of x. That is to say, you are going to hold on to f of x function without differentiating, and then you differentiate g of x function, you add a plus sign, then you hold on to g of x function and differentiate f of x function. You get f prime of x. So let's prove it and see. So we're going to use the first principle of derivative to have it proven. Sorry. So in the first principle, we have f of x and f of x plus h. So we told you f of x always it is the function that you are about to differentiate. So the function that we are about to differentiate here is f of x times g of x. So please don't say you divide this out by f of x and divide this out by f of x. No. We are only using f, but these two functions are two distinct functions. In some cases, they can be the same, but understand that these are two distinct functions, and the combination of them is equal to this function called f of x. So we have f of x is equal to f prime, or let's say f of x times g of x. This is the first one. So to get f of x plus h, it means we using this same function, but thereby replacing x now with x plus h. So we do the same thing on the right hand side. We replace x with x plus h. We replace this x with x plus h. So we have to put it back now within the formula. You have f prime of x equals to the limit. So wherever we see f of x plus h, we write this one. So we have f of x plus h times g of x plus h minus f of x is just equal to f of x times g of x all over h, as h is approaching 0. Now, note for this first principle, the limit of f of x plus h, right, minus f of x divided by h as h approaches 0 is just equal to f prime of x. So what do you notice? The function name here is f. It ends in f prime of x. So if this was g is going to end in g prime of x. If it were h is going to end in h prime of x, and so forth, right? So with that being said, since we have f of x plus h times g of x, f of x, g of x, we need to pair this f of x plus h with f of x and pair this one with g of x. But we cannot just do it here because there's no common factor. So we need to rewrite an expression wherein we can be able to get a common factor for both of them. So we can rewrite it as f of x plus h times g of x plus h. Now, what I can do here is I can add f of x plus h, right, times g of x, and then I subtract f of x plus h times g of x. Minus, I put the last term, f of x, g of x. Similarly, I could prefer adding f of x, g of x plus h times f of x minus g of x plus h times f of x. So it's like adding 0 to the problem, because f of x plus h times g of x minus f of x plus h times g of x is just equal to 0. So why did I do this? My intent is to do some pairing. Now, if I pair this expression with this expression, I will understand that f of x plus h and f of x plus h will be factored out. So what will I be left with? I will be left with g of x plus h plus g of x. But notice something now. If I take this and this, right? I'll take this and this. I will not have a negative within the middle. No, I cannot. There will be no negative within the middle. But what if I take this first term and this one? If I take this and this, there will be a, because the formula here has a negative in it, there will be a negative. So if I factor out f of x now, I'll be left with g of x plus h minus g of x. So g of x plus h minus g of x all over h, as h approaches 0, will just be equal to g prime of x. So that's exactly what I'm going to do. So remember now, this whole thing is being divided by h. So I have f prime of x is equal to the limit of f of x plus h, g of x plus h, minus f of x plus h, g of x. I took the first portion. This and this portion. Then I now move to the second and the last. So I have a plus sign, and then I'm going to have f of x plus h times g of x minus f of x, g of x, all divided by h. So I also divided this h, because remember it's the same when the denominators are the same. You can take one of them. So it's just the same. H approaches 0. So what I could also do is I could take the limit of this expression and as well take the limit of this expression. So I want to treat them separately. So if I do that now, I will have f prime of x to be equal to the limit. Now, also, what is common in these two terms in the numerator? There's a common factor, which is f of x plus h, right? And then I'm left with g of x plus h minus g of x all over h. So I want this thing to appear in this form. That's the reason why you saw that I factor out this guy as h approaches 0 plus the limit. So what is also common here? G of x. So I factor out g of x, and then I'm left with f of x plus h minus f of x all over h as h approaches 0. So if I further simplify it, I will have the limit of this first factor, f of x plus h, as h approaches 0. Note that the limit of one function times another function is equal to the limit of that function times the limit of the other function, right? So that's the property we are also applying here. The limit of this function times this function is equal to the limit of this function times the limit of the second function, g of x plus h minus g of x all over h as h approaches 0. And then plus the limit of g of x as h approaches 0 times the limit of f of x plus h minus f of x all divided by h as h approaches 0. So this now will be, now look here. I apply the limit right here. I put this guy right here. Right here, this one. Now, mind you, note that the limit of a function f of this x, y, z, right? F of h, x plus h, as h approaches 0 is equal to f of the limit of that particular function, x plus h approaches 0. So you see it? So if we apply the limit right here, what's where we see h, we put 0. What's where we see now x now is just a constant. So it will be x plus 0. So now your final result will be f of x plus 0, which will just be f of x. So this whole thing will just end in f of x times, now the limit of g of x plus h minus g of x all over h now is similar to this one. So this whole portion is equal to f prime of x. So if f is now replaced with g, this whole expression will just be equal to g prime of x. So the next area now we move to this side. The limit of g of x. So g of x is a constant because there is no h. So it will just be equal to g of x times limit of f of x plus h minus f of x over h. H approaches 0. So this whole thing is just equal to f of x, f prime of x. So we can clearly see that we can clearly see that f prime of x is just equal to f of x times g prime of x plus g of x times f prime of x. So you see, f prime of x, g prime of x, let's say f of x times g prime of x plus g of x times f prime of x. So this is the proof of this particular property or rule. But what if you have more than two factors? Assuming some problems may not appear in a form that you will just have exactly two factors. No. If we appear that you could have more than two factors, assuming you have a function like this, and it asks you to find the derivative x plus 1 times x plus 2 times x plus 3, and so forth. Three factors. And this one that we just from doing, it has to do with just two factors. So in general, if for instance you have three factors, for instance, if you have f of x times g of x times h of x. So this now will just give us, now in this case we held one function first, right? So you're going to hold two functions, f of x times g of x, and then you differentiate the last function, h prime of x, plus, in the next case, you hold another two function, f of x, you hold the first and the last, and h of x, and you differentiate the second, g prime of x, plus, you hold another two function. So we say we're holding g of x now and h of x and differentiating f of x. So we get f prime of x. So you see that? So if you have like three functions, it means that there will be three factors in each term and there will be three terms. And if there are three factors, you must hold two and differentiate one. If there were four factors, x plus 4, or 5 factors, x plus 5, you will have to hold 1, 2, 3, 4 and differentiate 1. Plus, you hold another 4, 1, 2, 3, 4 and differentiate the other. Just like that. So there will be 5 terms. So thanks ever so much for watching and see you in our next video. Thank you.